All right, we've all been there, right? You're standing at the gas pump, you see those numbers, 87, 91, 95, and you kind of just pick one? But have you ever really stopped to think about what they mean? Well, today we're going to decode that mystery. And trust me, what you're about to learn about the incredible molecular engineering that goes into every single drop of gasoline, it might just blow your mind.
So those numbers on the pump, they are absolutely not random. In fact, they represent a super clever solution to a really nasty problem that can happen deep inside your car's engine. And I'm talking about a problem that, if you don't deal with it, could literally destroy your engine from the inside out.
Okay, so what is this problem? It's something called engine knock. And yeah, it sounds exactly like what it is. It's this awful sound that's basically a cry for help from your engine. It's telling you something is going seriously wrong. So what on earth is making that noise? You know, a healthy engine has that smooth, steady hum. It almost purrs, right? But engine knock? Oh, it's the complete opposite. It's this sharp, metallic, pinging sound. And that noise is a huge red flag. It's the sound of chaotic, uncontrolled explosions happening inside your engine's cylinders. Your engine is literally fighting itself.
So here's the deal. Your engine is like a perfectly timed dance. The spark plug is supposed to lead, kicking off a tiny, controlled explosion at the exact right moment. But with engine knock, the fuel just goes rogue. It gets so hot and compressed that it ignites all by itself before the spark plug even gets a chance to fire. It's this rogue explosion that throws the whole engine's rhythm completely out of whack.
And yeah, this is a massive problem. These rogue explosions put an insane amount of stress on your pistons, which causes them to wear out way faster, and that means a shorter life for your engine. On top of that, it's just incredibly inefficient. You're basically throwing away gas money and pumping out more pollution. It's a total lose-lose situation for you and your car.
So, the big question is, how do we stop this from happening? Well, this is where our hero comes in, the octane number. That number on the pump is the rating system that was invented specifically to fight back against that damaging engine knock.
To put it simply, the octane number is just a measure of a fuel's stability. Or you could even think of it as its self-control. The higher the octane number, the more heat and pressure the fuel can take before it gets antsy and ignites on its own. It's basically a measure of how patiently it waits for the spark plug to give the signal.
Now, this whole octane scale is based on two very different chemicals. Think of them as the hero and the villain of our story. On one side, you've got isooctane. This is our stable hero. It's super resistant to knocking, so we give it a perfect score of 100. And on the other end of the spectrum, we've got our unstable villain, N-heptane. This stuff knocks at the drop of a hat, so it gets a big fat 0.
Okay, so here's a really important point that a lot of people miss. When you see octane 90 at the pump, it does not mean that fuel is 90% isooctane. Nope. What it means is that in a lab, that fuel behaves with the exact same stability as a mix of 90% of our hero, isooctane, and 10% of our villain, N-heptane. It's all about performance. Think of it as a performance rating, not a recipe.
But wait, there's a plot twist. You might think we just pumped this stuff out of the ground ready to go, but that's not the case at all. The raw fuel that comes straight from crude oil, it's actually got a super low octane number. It's totally useless for a modern car. So let's figure out why.
So when crude oil gets put through its first stage of refining, called distillation, we get this liquid out called naphtha. Now, naphtha is the raw ingredient for gasoline. It's our starting point. But by itself, oh man, it is terrible for your engine. It's so unstable, it's basically guaranteed to cause engine knock. So this creates a giant challenge for refineries, right? You've got this low-octane, low-value liquid, naphtha. How in the world do you turn that into the stable, high-performance gasoline that our cars absolutely need to run? Well, the answer is pure genius, and it all comes down to a really cool process of molecular rearranging.
The solution takes place in a very special part of the oil refinery. It's called the catalytic reforming unit, and this, my friends, is where the real chemical magic happens. The official scientific name for this process is catalytic reforming, but you might also hear people call it platforming, and that name actually gives you a clue about how it works. Platforming comes from the fact that it uses a catalyst made of, you guessed it, platinum. The entire purpose of this incredible piece of machinery is to take that useless naphtha and jack up its octane number.
Okay, so let's walk through the journey. First, they have to clean the naphtha really well because that platinum catalyst is super expensive and you don't want to ruin it. Then, they heat the naphtha up until it's crazy hot. We're talking almost 500 degrees Celsius and turn it into a gas. This super hot gas then flows through a bunch of reactors filled with the catalyst. And after that transformation, they cool everything down, separate out some super valuable hydrogen gas, and what's left is our stable, high-octane final product.
So what is actually happening inside those reactors? What's the secret? Well, it's not about smashing molecules apart. It's much more elegant than that. It's about giving them a complete molecular makeover.
Okay, so before it goes into the reactor, that naphtha is mostly made up of molecules called paraffins. The best way to picture them is like long, straight, floppy chains, kind of like a piece of uncooked spaghetti. And it's that long, gangly shape that makes them so unstable and so easy to knock.
But then, the platinum catalyst works its magic. It basically encourages those long, floppy chains to fold up on themselves and connect end to end, reforming into these beautiful, compact, stable little rings. These are called aromatics, and these ring-shaped molecules are incredibly strong and super resistant to knock, which is exactly what we're looking for. The process literally just rearranges the same atoms into a much, much better shape.
So, after this amazing molecular transformation is all done, what do we get out the other side? Well, it's not just one valuable product, it's actually two.
The main event, of course, is the reformat. That's our high-octane gasoline ingredient, and it's now packed with all those stable, ring-shaped aromatic molecules. But we also get this amazing bonus byproduct, pure hydrogen gas. And this isn't waste at all. It's super valuable. They use it in other parts of the refinery to help make even cleaner fuels, like low-sulfur diesel.
I mean, you really can't overstate how important this is. This process is the absolute heart of making modern gasoline. Catalytic reforming takes a cheap, almost useless liquid and transforms it into the high-value, high-performance fuel that, let's be honest, our entire world runs on.
So, the next time you pull up to the pump and you're staring at that number, remember what you learned today. It's not just a number, and it's not just about the price. It's the final chapter of an incredible story of molecular engineering. It represents a journey from a simple, unstable liquid all the way to a precisely crafted fuel, literally reshaped atom by atom, all to protect your engine.
And that really leaves us with one final important thought. You know, a lot of modern cars, especially ones with high performance or turbocharged engines, are specifically designed to run on higher octane fuel to get the best efficiency and power. So now that you know what that number really means, it's worth asking, are you giving your engine the fuel it truly needs to perform its best and last as long as possible?